Have you ever looked up at the night sky and wondered where the moon came from? It's not just a beautiful celestial ornament. Its origin story is one of the most dramatic and violent events in our planet's history. Today, we're diving deep into the cosmic collision that gave birth to our closest celestial neighbor. Let's rewind the clock about 4.5 billion years. Our solar system was a chaotic and crowded place. Dust and gas had coalesced to form dozens of young, rocky protoplanets, all jostling for position around a newborn sun. It was a cosmic demolition derby, and our own planet, a young was right in the middle of the action. In this tumultuous environment, Earth wasn't alone in its orbit. Another Mars-sized planet, which scientists have named Theia, was on a collision course with it. Theia, named after the Greek Titan who was the mother of the moon goddess, was a significant body in its own right. A world of rock and metal, just like the early Earth. For millions of years, these two worlds danced a dangerous waltz, their gravitational fields pulling them ever closer. The inevitable was about to happen. Then, the unthinkable occurred. The giant impact. Theia slammed into the proto-Earth, not head-on, but at a grazing angle. Imagine a cosmic billiard shot of unimaginable scale. The energy released was staggering, trillions of times more powerful than all the nuclear weapons on Earth combined. The impact was so immense that it vaporized huge portions of both planets. Theia was completely obliterated, and a massive chunk of Earth's mantle was blasted into space. The core of Theia, being dense and metallic, is thought to have merged with Earth's core, enriching our planet with heavy elements. What was left was a superheated, molten Earth, surrounded by a massive, swirling ring of vaporized rock and debris. This wasn't a solid ring like Saturn's. It was a scorching hot cloud of silicate vapor and liquid rock droplets orbiting our planet. Over a surprisingly short period, perhaps just a few hundred or thousand years, gravity began to do its work. The debris in this ring started clumping together. Small pieces collided and merged, growing larger and larger, sweeping up more material as they grew. This process, called accretion, eventually formed a single, large, molten body. Our moon. Initially, the newborn moon was incredibly close to Earth, maybe 15 times closer than it is today. It would have appeared gigantic in our sky, a glowing bowl of magma. But how do we know this incredible story is true? The evidence is written in the rocks. When Apollo astronauts brought back lunar samples, scientists made a startling discovery. The moon's composition is remarkably similar to Earth's mantle, but it is conspicuously lacking in iron and other heavy elements that would be found in a planetary core. This is exactly what you'd expect if the moon formed from the lighter, rocky material of Earth's outer layers, which were blasted away during the impact. Furthermore, the isotopes of certain elements, like oxygen, are nearly identical in Earth and moon rocks, acting like a shared DNA that points to a common origin. These chemical fingerprints are the smoking gun for the giant impact hypothesis. After its fiery birth, the moon began a long process of cooling and evolution. Its surface solidified to form a crust, but the early solar system was still a dangerous place. For hundreds of millions of years, the moon was bombarded by asteroids and comets, in a period known as the Late Heavy Bombardment. This relentless assault created the thousands of craters we see today. The largest impacts were so powerful they fractured the moon's crust, allowing magma from its still molten interior to well up and flood the basins. These vast, dark, smooth plains of solidified lava are what we call the lunar maria, or seas, which create the familiar man-in-the-moon pattern. The moon's influence didn't stop there. Its creation has had a profound and lasting effect on Earth. The moon's gravity stabilizes Earth's axial tilt. Without the moon, Earth would wobble chaotically on its axis, leading to extreme and unpredictable climate swings that would have made it much harder for complex life to evolve. The moon is also responsible for our ocean tides. The daily ebb and flow of the tides created intertidal zones, which many scientists believe were crucial crucibles for the evolution of life, providing a transition zone from sea to land. In a very real sense, the collision that created the moon may have also paved the way for us to be here today. Even now, our understanding of the moon's origin is still evolving. Scientists are using supercomputer simulations to model the impact in ever greater detail, testing different angles, speeds, and sizes for Theia to see which scenarios best match the evidence we have. Future missions, like NASA's Artemis program, aim to return astronauts to the moon. They will collect new samples from different regions, including the polar areas where water ice might be trapped in permanently shadowed craters. These new clues will help us refine the story of the moon's birth and, in turn, the story of our own planet's history. So, the next time you gaze up at that beautiful, silvery orb in the night sky, remember its violent and spectacular origin. It's not just a rock. It's a piece of our own planet, blasted into space and reformed into a constant companion that has shaped Earth's destiny. It's a silent testament to the chaotic, creative, and awe-inspiring power of the cosmos. Thanks for joining us on this journey to the past. If you enjoyed this cosmic story, be sure to hit that like button, subscribe to the channel, and ring the bell so you don't miss our next adventure into the wonders of the universe. See you next time.